Hello scholars, welcome. Mr. Hinkle here. Today let's talk about sedimentary rocks and a very specific type of sedimentary rocks, clastic or detrital sedimentary rocks. So objective, discuss the various types. I've got some examples. I want to show the differences here. So clastic sedimentary rocks come from weathered and eroded material of bedrock. You can think of it as sand at the beach. Sand at the beach is a bunch of broken down rocks that started in the mountains that tumbled down rivers and got deposited in the ocean, washed up on shore. Eventually they'll make their way to the bottom of a sedimentary basin to be deposited, where they will undergo the processes of compaction and cementation to lithify into sedimentary rocks. So that's a basic overview of how we create sedimentary rocks. We classify sedimentary rocks, or we name them by grain size, sorting, and the size of the grains. So let's get into it. Grain size, this is the Wentworth scale of grain size. That goes from, it's the actual size of the particles of the individual pieces of sediment that make up the rock. We've got clay, silt, sand, pebbles, cobbles, and anything greater is considered a boulder. So when we get into the actual naming of rocks, we're also looking at, are all the individual pieces of sediment the same size? That would be well sorted. Or are they all different sizes, poorly sorted? So here, our example of sandstone, all of the sand grains are the same exact size. In our example of conglomerate, that's a big chunk, smaller chunk, you've got some really small chunks, all different sizes. So we have poorly sorted and well sorted. Next thing is going to be rounding. Looking at, are all the particles rounded or angular? And we can really look at this by saying this clastic sedimentary rock has a bunch of angular pieces, whereas this clastic sedimentary rock has smooth, round sediments. Now this gives us indicators of depositional environment and of the life cycle of the sediments that were created or were forming these sedimentary rocks. So when we're wondering, how'd that get there? Why is this here in terms of geology? We look to the rocks, because the rocks hold the information, they hold the key for our understanding. So rocks are often made of the material that is nearby. The composition is going to be the types of sediment, the minerals in that sediment, and then the provenance is going to be, where did it come from? Did it come from nearby? Did it travel by rivers, long distances? So these kind of things can help us to understand depositional environments. More of that in sedimentary basins and sedimentary structures. So please look for those lectures if you're interested. Let's name some rocks. When we have a rock that is larger than gravels or larger, made of rounded pieces, poorly sorted, we call this rock conglomerate. Conglomerate. And we can see conglomerate rocks often indicate rounding material from fluvial processes. Maybe we have a gravel bar that's giving us the rock type conglomerate. Its counterpart, which we've already seen also, is going to be breccia. Breccia. This is an awesome rock. Angular pieces, as we can see here. In an aeolian environment, desert landscape, very dry, these rocks can lithify into a rock that is formed of large angular clasts. And we call this, I'm not sure what I was going to write there. We call this breccia. Lots of terminology in geology. Breccia and conglomerate. Moving to a smaller grain size now, sand can come in a range of sizes from fine to medium to coarse. And when sand lithifies into sedimentary rocks, we get the rock type sandstone. So sandstone most commonly is going to be made of quartz grains. Sand at the beach is generally quartz grains because quartz is a very resistant and hard mineral, resistant to weathering. But quartz is not the only type of sandstone, primarily quartz. We've also got arkose and greywacke. When we're including feldspar grains, we've got some arkose here, and I don't have a sample of greywacke, call out, which is a sandstone that has lots of lithic fragments or rock chunks inside of it. We're also often getting various colors. A muddy matrix in the greywacke can give it more of a greenish color. The feldspars can often turn the arkose into a reddish color. So, still sandstone because the size of the sediments are sand-sized grains. The whole reason we call sand at the beach sand is because of the size of the individual little particles of sediment that are there. How cool is that? Super cool. Going down the list of grain size, now we have siltstone, not our smallest particle size, but getting smaller. This is what, less than 0.06 millimeters? And last but not least, what we have is the smallest grain size, which is made of the particle size clay, giving us a very fine rock called mudstone. This is also, I've heard this called claystone. And a unique property that when same grain size, when mudstone aligns and has a rock cleavage that breaks into thin sheets, we call this rock shale. Finest grain size made of clay-sized sediment, no cleavage, mudstone, with cleavage, shale, but same grain size. So these will round out mudstone and shale. This will round out our clastic sedimentary rocks, rocks that are composed of the broken down pieces of previous rocks that were then lithified together and are identified on the basis of grain size, rounding, and sorting. We have conglomerate, breccia, sandstone, siltstone, mudstone, and shale. Thank you so much, and I'll see you again.